This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
All right, so what do we have for us today?
Well, today we are still in 3D, and we're going to be talking about solid shapes. So for our exordium, we've got this beautiful picture here that just, again, illustrates that when we chose all of the art for these covers, and for those of you who are maybe hadn't heard this before, every domain, which means every level, every age student will see the same work of art, the same quotation, and the same reflection every year. And that means that we can have one conversation as families or as communities with this beautiful invitation into that math conversation. And so as we look at this painting here, there's certainly some perhaps simple ideas that our youngest students can talk about when it comes to what we're looking at. And then there's definitely more, the older students can go as deep as they want to as they look at this. And the same with our quotations and our reflections. Those may seem more like our older students might dive into those words, but there's things in there that all ages can grab a hold of and discuss. And so I thought I would read the quotation by Isaac Newton this morning, because it just really spoke to me. And then you guys can share your thoughts either on the art or on the quotation. But he said that God in the beginning formed matter in solid, massy, hard, impenetrable, movable particles of such sizes and figures, and with such other properties, and in such proportion to space, as most conduced to the end for which he'd formed them. So what?
That's not at all like what the evolutionists tell us. You know, that they give you the feeling that it's all dust and ethereal things, not the solid, massy, hard. They don't usually use those words.
So do you know why some of the words are capitalized? It's like, are those the vocabulary that we need to focus in on? Or like, do you know why those particular words are capitalized? Properties, proportion, space? Is it just, are those just the math terms, or?
No, there. So we have stayed true to wherever the quote originated, however he wrote it, that is how we have presented it.
That's all the nouns, right? It's all the nouns that are capitalized.
Mm-hmm.
They
Yes.
still do that in German. I think they used to do that in other contexts too.
That may very well be it, Jana.
Yeah, they were very free with capitalization hundreds of years ago, intended toward capitalizing nouns.
Randa, Clay, sometimes when you guys edit my works, I want to be like Isaac Newton. Okay. So I just really like what he says and all that, though, because of all the math words. And obviously he was a mathematician, but they aren't words that are inaccessible. Like sometimes our quotes are a little bit difficult to understand. But I think this sentence is, you know, you could talk to your fifth grader about what it means.
Yeah, it almost sounds a little like a fifth grade. Some of the words, like massy, that's I know what that means, but I didn't know that was a word.
I like that it implies that he started with the end in mind. I think that's what he's saying. So that God has a purpose for everything, and not like there's not a random part of creation that slipped his mind or just happened to be. Everything has a purpose and is formed for that. That's kind of cool.
Conduced is such a really good word, but it doesn't get used often anymore.
So Amy, we have an easier time believing this sometimes, don't we? Like if I always pick examples just looking out the window, right? And so just looking at a tree, there's bark and there's leaves that you can see on a tree. And they each serve a different purpose. And we don't ever go, well, gosh, why? I bet that leaf wishes it was bark, and I bet that bark wishes it was a leaf, right? We accept that God created them that way for a purpose, but how often do we fight against how he created us? Right? I wish I had beautiful straight hair that was never frizzy, right? And we fight it, and we fight it, and we fight it instead of rejoicing that this is the hair God gave me. And so as I read that, it just reminded me, and I perhaps having a daughter just emphasizes that for me, how important it is for us to teach our children, right? That, and our boys, right? Our sons as well, but that God, and I love that way you said that, Amy, that there's an end. And the Bible tells us that, right? He created a work for us to do that he then equips us for. And this just reminds us, right, that God specifically created all of us, right, in our 3D-ness for an end.
I feel like the wheels are turning in my mind about the conversation I could have with my students on just this quote. I just think they have so much to say, even as a 7th grader. I think that they have a lot to add to what they think the verse means, or I keep saying verse, the quote, you know.
Yeah.
It's a beautiful thing that with a quotation like this, that we can all bring something to the conversation, and I can learn from those Challenge A students, and we could learn from a 5-year-old, and all right, that we can learn because we all have different perspectives, and learning from one another is a beautiful thing. All right. So moving on, so this week, as we look at the language and the order of mathematics, I wanted to talk about the idea of concrete versus abstract, because a lot of what we deal with in mathematics feels very abstract. And so when we think about the concrete, right, as we go back and we look, we talked about lines back here. Let me turn my, oh, it is on. Nope. Pen, right? We talked about lines back here. We talked about angles here. These are all things that I could see, right? I can draw a line. I can draw an angle. I can draw a curved line. Right? I can draw these things and see them. But now that we're up here in human space, right, I can actually, especially when we talk about solid shapes, I can actually hold on to something. Right. So last week we were holding on to a tissue box to help us see that, because having that concrete example sometimes is really important to helping us to grasp abstract concepts. And so Lee has really emphasized throughout the curriculum the importance of using words, symbols, and images. Right. So the symbols perhaps sometimes feel the most abstract, because they're unfamiliar. We don't use them in all of our strands. We don't use them in everyday work. They're specific to when we're working with mathematics. And then we connect those with words. And sometimes our words are more precise in mathematics, and sometimes our words are less precise in mathematics. And that's led to lots of conversations over the years of what's the right word and what do we really mean. But then oftentimes when we take those symbols and those images and we combine those words and symbols and we combine them with an image, that's when we can have that sort of light bulb moment and go, oh, right, that's what you mean. Because I could write this. right? And they're symbols. And if you're not familiar with the symbols, they don't mean anything. But then I might say, well, let me read it for you. And it says segment AB is parallel to line CD, and the words may help. But then if I was to draw, my pen is a little bit off of, there's my line, and here's my segment. Right. And so now you go, oh, that's what you mean. Right. And so this idea of the concrete and the abstract working together to help us understand. Was somebody saying something?
One thing I think though, that what you pointed out in that example is how math conversations force the person trying to teach to really be clear, because we tend to use so many pronouns, and pronouns get us in trouble all the time, and we say that thing or that line when really we meant a curve or a segment. And the thing that's so interesting to me about math problems is the majority of them in kindergarten through 12th grade or through Abecedarians and Challenge is they're short. They might have 4 or 5 steps at the most to them. And so it's this level of precision in the problem itself, as well as teachers to student, it requires a lot of precision. And I think we see that really clearly when we study scriptures and how Jesus picked his words and Paul picked his words, but somehow we don't make that analogy to instruction during a math problem. So I appreciate you showing us these examples.
Lee, that just reminds me that we talked about a question that came in last week about the order of operations, and somebody who had been taught the order of operations a little bit differently. And there's this proliferation on the internet of these sort of like, what's the answer to this? And they write some horizontal math problem, and then people argue, well, no, it's this and this, and the order of operations. Well, if you do this, all right. But the simple answer really is let's be clear, right? Don't omit a symbol just because you think it doesn't need to be there. Let's be really clear about what it is we want to communicate. And just when you said that about scripturally, it made me think about how when you go back to the original language, right, that we may have one word, love, in English, but that in Greek, there were several words for love. And so knowing what specific word was used is so helpful in really understanding what the passage means, right? That they were specific. And sometimes our English loses some of that specificity. And so it behooves us to go back and say what was being said. And the same with mathematics, right? Let's be clear. All right, so we are on week 20. We are in human space 3D. So 2/3 of the way through the year. Well, not this year, but the year of the math map here. And so this week we're going to talk about solid shapes. And I thought we would take some time and compare the abstract with the concrete, since that was what we were talking about. And I've pulled up 2 pages of the charts from this week, page 1 and page 3. And you'll notice, or I'm sorry, it was page 2 and page 3. You'll notice at the top, it says sphere. And on the bottom, it says geography. So which one of those is abstract and which one of those is concrete?
First one is abstract. This geography is the concrete one.
Right. Right. Yeah, absolutely. Right. Because we can all put our feet down, right? We could all go outside and take our shoes off and actually stand on our globe, right? And we can feel it and we can touch it. And if any of us want to spend a few $100,000, we could actually go up into space and look down on it and see it, right? So we can touch it, we can see it, we can smell it, right? We can hear it, right? So we can really experience it with all of our senses. So let's look at that first question, and I'll give you a minute to think about it. On a sphere, if we were to read this about the poles, it says the endpoints of a diameter, right? So on a sphere, can our poles are at the ends of any diameter. But on our globe, how many diameters can we draw given our poles?
I'm not sure what you're asking, because the Earth's not quite round. Is that why you're saying that, or?
Well, no, because if I was to pick up a sphere that wasn't our globe, right? I could stick a pin through anywhere and say, here's a diameter and here are my poles, right? But on our Earth, can I do that? Can I just pick any diameter?
There's just one
Oh.
axis that would be the diameter.
Gotcha.
There's just one, right? Because we have the North Pole and the South Pole.
And it
and-
spins, and we know how it spins.
Yes, and it was chosen specifically because of that spin, right? So it makes sense to say its axis is going to be the diameter that we're interested in for determining those poles. Right? Now, when we're talking about this, just as a side note, are we talking about the poles being true north or magnetic north?
Magnetic.
We spin on magnetic, don't we?
No, I think we spin on our true north, because that magnetic north is actually moving around. It moves. It doesn't stay in one place. And so it has to do with that magnetic field around the Earth, obviously, and which is a little bit different, but it actually moves. So when I like just to have that conversation, because if I'm navigating, do I want to navigate towards a true north, a fixed point, or towards a magnetic north, a point that's moving?
True. You would want the true north.
I would want the true
not
north,
moving
right?
around.
And we know that realistically, when we use a compass, we have to correct it, right? So if you look at charts, they'll have a declination, they'll tell you how much it's moving and how much you have to correct your compass by to get to true north. But right, spiritually, do we want to chase after truth or something that's changing? So when we think of what God can teach us here, right? When we compare those two, right? Sometimes it might be tempting to chase after a fad, right? And God's always saying, no, there's one true way. Follow that. So let's look at again our sphere and our globe, and notice here that we have meridians on both. And what do meridians all intersect?
The poles?
The poles, right? And what do we call the meridians in our geography?
No.
Longitude.
The longitude, right? So there are lines of longitude, but there's our concrete longitude that corresponds to our abstract meridians. And how about both on the sphere and on the globe, the equator is equidistant from what?
No.
From
The poles?
From the poles. So notice, as soon as I pick that diameter that I'm interested in, and I say that gives me my two poles, they're fixed, right? And as soon as I knew where my poles are, now I can define my meridians, and then I'm going to have to, then my equator is fixed. So notice how once I make one decision, all of these other things fall into place, right? They're not, and and again, we can see how that works on our globe and understand that that abstract idea on a sphere. And how about the idea of a radius? Because somebody sort of already mentioned this, that a sphere has a uniform radius. Does our globe? No. Right. And so that's actually that word geoid there. If you can read that, it says it's the surface of the Earth's gravity field and it approximates mean sea level. Right. So our globe is kind of this odd shape, but we approximate it as though it's a sphere, right? We like to think of it as though it's a sphere because that makes things easier.
So geoid is a noun, not an adjective.
Yes, that is correct.
So let me just ask, so like the radius that you're talking about would be like from the center to maybe the one, it would be different if it went to the top of Mount Everest versus the bottom of the sea. So you're taking into account the surface fluctuations of the Earth for the radius, but not the fact that it's a different shape than
Right.
a perfect sphere. So you're taking those in. Okay, that's good.
Well,
Thank
the
you.
other thing is it's also not a complete perfect circle because it does spin and that forces it to go fat at some areas and flatter at the poles. And then the other one is going to remember the moon's always pulling on it. Yeah, the Earth, and this is why you need is that what you say it? Geoid?
Geoid?
Geoid, there we go. That's why we need this term. It's very fascinating. The New York City moves an average of 14 inches up and down every single day. But 14, right? It's affected by the tide just like water is. But because the Earth is so massive, we don't even feel that 7 inches up and the 7 inches down. And that's everywhere you live, it moves.
So here's a great thing, right? That our the students involved in the masters are thinking about, right? When we think about a mathematical model, like we take the sphere and we say we're going to use the sphere as a model for our Earth, right? Because can any of us really, right, comprehend all of those different variables when it comes to the Earth, right? How the radius changes and the shape's not perfect and the moon is pulling things and gravity's weird and
we're spinning super fast.
We're spinning and
and
there's
flying through space.
All these things happening, right? And so what do? We go, I can't possibly conceive of all of these things. So I'm going to pretend, right? I'm going to simplify our concrete thing with this sphere. And I'm going to simplify it because I'm not going to worry about all of these little bumps and I'm not going to worry about gravity and I'm not going to worry about the moon and all of these other things. I'm just going to pretend that it's this nice sphere, right? And now I can define things like latitude and longitude and I can find where they are, right? And I'm going to think of it in this much simpler way. And that's what a mathematical model does. It says, take these really complex things and pick out their essential qualities and then describe it with just those essential qualities and don't worry about all the other stuff.
But I have to know what you are categorizing as a simple thing or a not simple thing to make sure we land in the same result area, right?
Yes, Sandy, that's right. That's right. What is simplified and what is right? So simplified is usually anything that has less detail or less complexity, less pieces or whatever, but deciding what are those essential things, right? And so when you watch the weather, right? I was watching the weather last night and she said, we have exclusive access to the European model. right? And then there's the GFS model, and then there's like the GFS 95 model, and then there's, right, anybody that's watched the Weather Channel knows that the spaghetti plots represent all these different models because different people think that, well, no, maybe this variable matters and this one doesn't. And somebody else is going, no, 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 you've got that backwards, right? So all of those different models represent people who have not agreed on one simple set of essential characteristics, right? They're all picking different characteristics. And depending on how much computing power they have depends on how many variables they can track, right? But certainly none of them track all of the variables. And so this is an opportunity to stop and go, okay, right? Think about our world, the concrete, the reality, and right? What do those verses in Job say about how God is involved in his creation? He says how
A lot, he's involved.
right, he's involved. It's not right. It's not the Clockwork Orange. He's involved, and he's got storehouses laden with snow, and he says to the tide, come here and no further, right? And he knows like every little piece of it. And how limited are we as men, right? That we're like, I can't deal with that. We're just going to pretend it's a nice sphere. Right? So it's just an opportunity for us to stop and compare the two and rest in how amazingly great God is. Right? So, all right. Moving on. So next week, we are hoping that we will have a new graphic to share with you as to how everything is going to be released over the next few years. When you see it, you're going to be called to pray for all of us that are involved in this, because it's an aggressive and ambitious schedule. And so Lee is going to be working very, very hard, as we all are. And so when you see that next week, just be ready to like hit your knees and be praying for us all as we get all of these pieces together. Be praying for us now, because the next 6 weeks are going to be very full weeks as we finish up details on the complex. Jill, you are loved by God and by us.
Yes.
All right, it finally clicked. Okay, so let's go ahead and take a look at the naturals. That's the book that we're talking about this week, is looking at those naturals. So look at what's here on the page. This is one page from our naturals. And think about what kind of a base defines a cone. And then what kind of a top defines a cone? If you were to describe it to somebody, how would you describe it?
The base is the circle and the top is the triangle.
Okay, so we have a circular base. Does it always have to be a perfect circle?
I think so. No.
No, it just needs to be circular, I think.
Good. So it has to be
All
circular.
of these things are cones on this page. Is that right?
Yes, except down at the bottom, there's some other things
Oh, right,
going.
right. Yes.
Yes.
Because they have other names if they have another kind of base, but you've got your
Right.
circular and your ellipticals.
But this oblique thing is still a cone.
It is still a cone, yes. So we see when we look at a cone, it's something circular, right? And when we think about with our kids, what are some concrete examples that we could give them of cones?
Ice cream.
A sugar cone, not a regular cone.
Well,
Right,
Orange
orange
things
things
point.
you've got to
Good
drive
point.
around.
yes, so you've got traffic cones or sports cones, you've got ice cream cones, And it could be a nice, right, sugar cone has a nice circular base and it's usually nice and right. We'll talk about that in a minute. But a waffle cone, right? If you look at it, if you were to stand it up, right, it's going to sort of look like it's oblique. It's going to be leaning and it's going to have more of an elliptical base.
Right.
And so then you always talk with your kids, right? Which one maximizes how much ice cream you can get in it?
I guess I was thinking of those cake cones that have the flat bottoms.
The flat bottoms, that one doesn't
You could
work.
compare, why is this not a cone, even though we call it a cone in this context, the vocab fits, but not in the mathematical.
That
That's-
reminds me of a pine
yeah.
cone, Jana, right? The idea of, we say cone, but if you look at these shapes, you know, a pine cone, does it really fit the definition mathematically?
And yet it's
But-
conical, which is an
Mm-hmm.
adjective that means referring to a cone. It's close, but it's not the same thing.
Yeah.
It's a great example, isn't it, of how our language may be less specific in some contexts and more specific, right? So math here is going to be very specific about what makes a cone. Jill says a party hat. So party hat is a good example of a cone. And so what kind of a top? Look at the very top of all of these cones. What
It's a point.
a single point. Now, isn't that amazing? Right, when we think of the solid, right, that the very top of a cone is a single point.
Which is nothing.
I was just getting ready to say that, and then I thought, but can I say that? Because it is, but it's representing, I don't know.
But you know it's true because the ice cream leaks out.
Right. Exactly.
Yeah,
So
I
you-
was laughing because like in my challenge classes, sometimes like we get when we start to confuse abstract and real, we get into this, like, oh, well, the point is nothing. Well, abstractly it's nothing, but a cone in the physical world is something. So it just being careful of not applying characteristics to real world objects that only exist in the abstract and vice versa. It's makes for interesting conversation.
So
I think
here's
that was Kirsty's whole point between sphere and globe. And also I think so you're right, Carrie. And so I think the majority of jokes, of course, in this world are puns, because you use a word one way and then the audience expects you to use it a certain way, and you end up using it slightly different. So mathematics just opens you up to a whole world of comedy.
Mhm.
So is a funnel a cone? And
yes.
the other way, even though all the descriptions you gave, the round base was on the bottom, can a funnel be on the top and then come to the point at the bottom? And if it is, does that mean a tornado is a funnel? A cone?
Yes. Yeah, Sandy, that's a great
cool.
point. That yes, a funnel would be a cone. A tornado is a cone. How about a megaphone, right? The megaphone has a cone shape, even though it's sideways. So yeah, so all of those things, when we're thinking about them as cones, can be rotated any way we want to. We just tend to think of them, draw them this way because it's habit, I think.
Well, it's still called the base, even if it's, no matter where the circular part is, it's still gonna be called the base, but we tend to
Base.
think of a base as being what would sit
Bottom.
ground or.
That's a good point. It's a very good point. Sorry. All right, so take a look at the middle right, and they're talking about intersections, right? So what the idea here is pointing towards is conic sections, and so you don't necessarily need to know that, but So we're looking at intersections between a cone and a plane and different ways that it could intersect. And there's no right answer. So share whatever you think. But which cross section do you think best preserves the essence of the cone?
I would say the first one, because if you only look at what's above the plane, the shape that we're all familiar with a cone is still there. It hasn't been dissected in a different form to give it something that looks new.
And yet that's the same as you would get if you did a cross section of a sphere, it would look like that.
Mhm. That's good.
You
Or a
almost need them
cylinder.
both, top and the bottom. You need them both, don't you?
I was thinking the last one, just because you can see the whole thing. You know, you can see the top of it and where you see the base and the point. Well, I guess you can't see the whole thing, so.
It's a great illustration, isn't it, of what gets lost when we lose a dimension?
Like the
Yeah,
blind
so-
man telling the elephant, you know, feel his tail, and they feel his
Mhm.
trunk, and they feel his side.
Mhm.
And I know I've challenged you to do this before, but think again, right? So what if Christ just was in 4D, right? So I'm not saying he lives in 4D or he's limited in any way, but just imagine if Jesus was 4-dimensional and he came and dwelt in 3 dimensions, right? How much do we lose by only seeing 3 dimensions of Jesus?
Pretty much all of it. And yet he's so gracious to show us that slice.
Through a lattice.
Just a great analogy.
And we think about the Gospels, right? When you read about the Gospels and how each Gospel had a different purpose, right? To show us a different aspect of Jesus. It's kind of like they said, okay, well, here's the cone, right? I can't show you all of the cone, but here's the circle. But sometimes it might be an ellipse, and that's okay. And then it's got a point on the top, right? So it's like taking all of those pieces, trying to give them to us. And then how many of us think we know Jesus, right? Oh, well, I know that. Right? That we get so prideful because we think we know something. And this just reminds us, right? There's so much that we cannot conceive of. All right. So now looking at it, there's some up top, right? We see right and oblique, and then right circular and oblique elliptical. And then down at the bottom, we've got right solids and oblique solids. Any idea about a detail that would define a right solid? Or how would you describe a right solid versus an oblique solid?
Just
There
the
is
right angle?
angle between the line that the radius of the base, and the line that would connect the center of the base to the point.
Yes.
Ish.
So for some reason, my PowerPoint has decided to like not let me draw, there we go. Now it came back. But yeah, absolutely. So that right, now you can see where I was trying to draw it, right? That right angle is exactly the thing that defines a right solid, right? When we look at that axis coming down to the base, that it's right when it's a right angle. So what does an oblique solid look like? How would you
Well, oblique,
describe it?
the oblique examples look tilted.
Yeah, there's that slant or that tilt off of right. In our real world, do you think we have more right angles, or do you think we have more right solids, or do you think we have more oblique solids?
Oblique.
Well,
Think
in
of a tree.
construction, we use more right solids. but in nature, I think we see more oblique.
Structurally, the right solids would be much more what's the word? Reliable, stable. I don't know. Right?
Okay, so that, right, so if when we're constructing things, that idea. So how many of you have ever built anything? How often are your right angles perfectly right?
Mhm.
Or if you've tried to wallpaper your house, how often are your walls perfectly perpendicular?
Hard.
The older the house,
They're
the worse
not.
it is.
They're not.
Out of
No.
square. That's what they say.
It's just
But the
one
illusion
more
is that they
one
are.
more example of how, right, our limitations as humans, that we can see, right, when we look at mathematics, God is always pointing us to this idea of what is perfect, right? He gives us this, through mathematics, he gives us this opportunity to interact with something that is perfect and lined up, because our reality so often is not. Right. So the last thing before I click through, I just wanted to point out that one of the things that our tutors have to keep talking to our parents about is when you're looking at this page from the naturals, and it really wouldn't matter, right? Next year, it'll be a student looking at a complex page, right? If this is the first time a student has seen this, right, they are firmly in the grammar stage, and they are just picking up the language of mathematics. And a lot of it is through memory, right? So they may not be defining or comparing or any of those things, right? They're just going, okay, I'm going to remember that this is a right circular cone and this is an oblique circular cone. And one day, I'll know what those things mean. But this year, I'm still in the grammar stage. For most of the parents who are looking at this, is this familiar or unfamiliar?
Unfamiliar.
If it's unfamiliar, I mean, probably you recognize some, but a lot of it's going to be new to parents, right?
Some of it's going to be new, but a lot of them are going to have some remembering. They're going to go, right, what you just said, it may feel unfamiliar, but they're going to go, well, I remember when I did this, and I don't remember the details or anything, but I remember it, right? That it's not a first time. And when it's our second or third time seeing something, what stage do we want to move towards? The dialectic.
Dialectic.
So there's going to be this tension, right, between the parents and the students, where the parents are going, we need to understand this. And the kids are like, no, right, I'm still in the grammar stage. And so I just want to encourage us. I know that there's a lot of people on here that are going to be leaders in talking about math in their communities, right, to encourage parents to enjoy their dialectic, right, independently of their students who are still grammarians, right, and to celebrate the grammar that their students are picking up, even while they're eager to understand, right, but not to try and like force that dialectic on a student who's not ready. And so reminding those parents that it's really exciting for them to be making those connections, but to be patient with their students who aren't quite there yet.
So one thing, looking at this page, I realized we got to be really just saying over and over again. So I don't expect a kindergartner or first grader to be able to read any of those words. I do expect, as an example, the right solids at the bottom, that they notice that, oh, I matched the cone, and maybe there's something else I could match beneath it. Those words that are too hard for the children are there for the parent, so that they read and get the right words. If all my child did was the tracing and didn't know enough to do anything else because they can't read the instruction and I wasn't there, well done, they did that. And so, and that's the beauty of trying to make it so that it's mapped, so that maybe an older sibling can look over and say, yeah, just connect them, match them up is all you're expected to do, because they remember doing it And they're doing something similar. They aren't matching necessarily, but they're looking at some characteristic of right solids versus oblique solids on their page.
So would this be maybe like a read aloud type activity?
Well, if you
With the
look
words
at
or-
some of the pages of the CC, on the CC Connected one, that's naturals, at the bottoms, it'll say, read the words on the page and then
Mhm.
discuss the images on the page and then read the symbols on the page.
Mhm.
Just to remind parents that you don't have to do that every day on every page. Don't do it. You'll make everybody upset. But to remind you that, you know, if this lesson's too hard, just read the images on the page and be done. Or
Okay.
maybe discuss oblique versus right and be done. That we know there's way too much for anybody to do any level of the domains that are graded like they are. But that's because every now and then you've got kids who really love math, or parents who are really good at tutoring and they want to be challenged. But meanwhile, everyone has permission to just really look at the page and decide, okay, what's familiar? Let me do that. And let me tackle one unfamiliar thing. And well done. Turn the page and try again.
Yeah, one of the things, just when Lee said that, one of the things I've heard from her over the years is to use the book and not let the book use you. Right. And so when you see this page, just as she said, right, with our naturals, it may be more common that people get every page done, but they don't have to. Right. And so freeing parents to look at this page and say, how do I use this page to best teach my child? Not we have to check every box. So.
We need to be more analogous to our Bible studies. We pat ourselves in the back, and we should, when we've had a good 5-10 minute devotion with our kids, because we know we're milking a cow. And if we do it every single day, year after year, we're going to learn our Bible. But we don't give ourselves that same permission in anything else that we do that's school related.
Aren't we lucky that Lee has that attitude and is designing a curriculum to encourage us not to try to like teach our kids everything in a single year, but just to be persistent and trust that we're going to get there in the end. All right, well, we are over time. Thank you all for sticking with us. Next week, September 27th, my oldest child will become an adult. So that is a very emotional day for me. Next week, so I have one more week with 2 minor children, but we will be talking about locations, and we look forward to seeing you all then.
Thank you, Kirsty. It was great. Bye, everybody.
Thank you.
Bye.